Here is Fall 2022 Exam 2 Question 2. So you are in a role of a hacker trying to break down a hash table. The information collected so far indicates that the hash table uses quadratic probing with h, k, and I equals k plus I squared mod m for collision management, and its current capacity is m equals 9. So the current state of the table is below. The system is nearly overloaded and will collapse if the next item inserted causes at least 4 probes. And as an attacker, you're considering inserting the following keys: 16, 35, and 10. Which, if any, of these values would bring the system down if inserted next? So here we see that we are dealing with quadratic probing. So what exactly is quadratic probing? Let me get this a refresher. So quadratic probing has the k and I as elements. So we have a hash function k and I equals k plus I squared mod m. So here we are given that m equals 9, but we'll deal with that later. So basically we're trying to insert either 16, 35, or 10 as the k value because that's the input value. And then I is used to increment one by one when an element is already inserted. So for example, if we were going to insert in this first square, if this first square is already taken, it would go to the next square. So basically it would increment by 0 to check first, and if there's already an element, it would go to the next box because it would be the element plus I squared, so plus 1 squared. And then if 1 squared is also taken, then it would insert at the next one, so 2 squared, so that would be 4. So it would go 1, 2, 3, 4, so it would go here. And then after 4, it would go to 3 squared, which would be 9. So it would insert 9 elements after the original element. So that's basically the basics of quadratic probing. So here we are given this top sequence, and we are trying to figure out which of 16, 35, and 10 would actually bring the system down. So basically causing at least 4 probes. So first, there's 2 ways actually. First way, it would be like brute force. So just checking that 16, if we insert h16 and 0, that would give 16 plus 0 squared mod 9. So 16 plus 0 squared is just 16 mod 9 would equal 7. So checking 7 in this array, in this hash table, we have 0, 1, 2, 3, 4, 5, 6, 7. Here we go. So 16 would be here. So clearly 16 has a spot to be inserted in. So 16 would not bring the system down because it only just inserted in first. And then next we can check 35. When we check h35 0, that will give 35 plus 0 squared mod 9, which this would equal 8 because 4 times 9 equals 36, and 35 is missing 1, so the remainder will be 8. And clearly 19 is already a spot for number 8. So that means, no, I meant a check mark. And then that's impossible to insert. So you would increment I to check for the next probe. So that would be h35 1. So that would be 35 plus 1 squared mod 9, which would equal 36 mod 9, which is 0. And 0, clearly 17 is already there. So you gotta go to the next one, increment I. So here 35 2, that will be 35 plus 2 squared. This would be 39 mod 9. So that will be that will be have a remainder of 3, because 4 times 9 plus 3 equals 39. And when checking here, 0, 1, 2, 3, there clearly is a space. There's a space for 35. So 35 would land here after 3 operations. So clearly you can see that 16 and 35 won't bring the system down because it did not satisfy at least 4 probes. So the answer would be 10. And of course, you can also run through all of the age 10, 0, 1, 2, etc. But I think there's a better way to check why 10 would be the correct answer. So you can see that I is incremented. So every time it will be like 0 squared, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So those all equal either 1, 0, 1, 4, 9, 16, 25, and there's 36, 49. And when we take modulo 9, 0 modulo 9 of course is 0, 1 modulo 9 would be 1, 4, 9 modulo 9 would be 0, 16 modulo 9 would be 7, 25 modulo 9 is also 7 because 9 times 2 plus 7, and then 36 modulo 9 is 0, 49 modulo 9 is 4 because 5 times 9 equals 45 plus 4 equals 9, and then if you continue the 64, that will be 1 because 7 times 9 equals 33, 63. And you can clearly see kind of a pattern. It goes like 0, 1, 4, 0, 7, and it goes to reverse 7, 0, 4, 1. Okay, I can show you 81. 81 will actually just go to 0 because 9 squared equals 81. So yeah, you can see clearly of a pattern that kind of reflects 0, 1, 4, 0, 7. And of course, that's the set 0, 1, 4, 7. So those 4 elements are the only possible remainders of I squared modulo 9. So clearly, you can try to append k with I. So k we're given k is already 10, modulo 9 will be 1. So adding 1 to all of those, that would give 1, 2, 5, and 8. And you can see that 1 is already taken, 2 is already taken, 3, 4, 5 is already taken, 6, 7, 8 is also taken. And this is the only possible way to bring the system down because 10 gives only 4 remainders which already have spaces to begin with. And 16 and 35, so we can see that 16 modulo 9 is already 7, and 7 already has a spot. And then 35 modulo 9 would be 8, but then when you add 8 to each of those numbers, that would be 8, 9, 9 would become 0, of course, and then 8 plus 4 equals 12, mod 9 equals 3, and then 7 plus 8 equals 15, mod 9 equals 6, and of course 3 already has a spot. That's how you check if there's a spot to insert 35. I think this is a little quicker, but I guess both brute force and a more conceptual way to check this would work in an exam scenario. So yeah, basically only 10 works, and surely we get the right answer. Just go for it. Include my user ID. And yeah, the answer is correct because of this solution. Thank you for listening.